Some people are still a little bit worried about those two equations from topic 14 that we met early on, so this is just a quick video to try and help with that. Okay, we're going to have a look at both of these equations, which I've taken a copy of from the formula sheet, and just have a think about the units that they're measured in and some conversions between those units. So if we start with the thermal energy that's used when we're changing state, okay, this is the one that's all to do with specific latent heat, or the hidden heat that's not rising the temperature anymore, it's changing the state. So specific latent heat, this one at the bottom here, is all about changing state. Okay, so if we're melting or we're boiling, a change of state, this is the equation we go to, because the specific latent heat is to do with how much energy is required to change the state of a certain mass of material. So the thermal energy, Q in this equation, is measured as a standard in joules. That's the standard unit for energy. The mass is measured in a standard unit called the kilogram. So the latent heat, the specific latent heat, if we rearrange the equation, we end up with energy divided by mass. Therefore, we end up with joules divided by kilograms. So we're saying that the latent heat is measured in joules per kilogram. How much energy for every kilogram of mass is required to change its state. Now, where we might have to convert is sometimes we're given a mass in grams and we need to change that into kilograms. Well, 1,000 grams is equal to 1 kilogram. So if you want to go from from grams into kilograms, you would need to divide by 1,000 to do it. For joules, sometimes 1 joule is a small amount of energy, so sometimes you're given joules as kilojoules. Now 1,000 joules is equal to 1 kilojoule. So if you had to convert from kilojoules into joules, then you would times by 1,000. Okay. So if we have a look at the other equation, so this one for specific heat capacity, so this is all to do with raising or lowering the temperature of something, but keeping it in the same state. So if it's water as a liquid, it stays as a liquid, but you're making it hotter or you're making it colder. So let's focus on the units here. The change in thermal energy is still to do with energy. It's still got the standard unit of joules. The mass is still in kilograms. We'll come to specific heat capacity in a minute. The change of temperature, now the standard unit for the change of temperature would be the Kelvin. Okay, but a change in temperature in Kelvin, so a change in Kelvin, is going to be exactly the same as any change in degrees Celsius, because changing between 0 and 1 degree Kelvin is the same as changing by 1 degree in degrees Celsius. So you will see this in both forms, because we tend to use degrees Celsius as a much more convenient unit most of the time. So sometimes you're going to see it in Kelvin, or sometimes you're going to see it in degrees Celsius, but it won't matter in terms of the change of 1 Kelvin is equal to the change of 1 degree Celsius. I hope I explained that clearly then. So if we have a think about this equation, if we were to rearrange it for the specific heat capacity, we would end up with the change of energy divided by the mass times the change of temperature. So in terms of units, we're looking at joules per divided by kilogram Kelvin, or joules per kilogram degrees Celsius. Okay, and again, if you had to do conversions, if you were going from grams to kilograms, you would divide by 1,000. If you were going from kilojoules to joules, couldn't find it on the page there, you would times by 1,000. I'm not really sure if that's what you wanted, but I had a go. You have to let me know if you need something different than that, and if it was useful I'll leave it on, and if it's not useful I'll take it down. If you are worried about standard units and converting units and multiples, submultiples, I would recommend having a watch through the couple of key concept videos that I have on this channel.